Two-sided marketplaces are a great way to resolve supply and demand inefficiencies. There is such high demand for great programmers, but there is only a limited supply. So why would it make sense for a great developer to use a terrible tool like a job search engine? That's why I love Hired.com. Developers can sign up at hired.com/softwareengineeringdaily and be connected with 5 great job opportunities at companies like Stripe, Uber, and Facebook. If you're a developer, you shouldn't settle for a mediocre job. I know this from personal experience. It will stunt your career growth. Hired will give you a $2,000 bonus if you find a job. And if you go to hired.com/softwareengineeringdaily, you will get an additional $2,000. It costs you nothing to try it out, and it's a fun process. I urge you to try it out. Michael Hausenblas is a developer and cloud advocate with Mesosphere, and he joins us to talk about cluster computing and how to manage the data center as an operating system. Michael, welcome to Software Engineering Daily.
Thank you very much for having me, Jeff, and I'm looking forward to discuss that exciting topic with you.
Awesome. So you've been observing this space for much longer than I have. Could you start by giving us some historical context about cluster computing and how we got to where we are now?
Right. So, depending on how far we look back in history, but obviously there have been sorts of clusters like, HPC and stuff for decades around. But really seriously, I would say the last 15 to 20 years, companies like Google being the trailblazing examples for applying these large scale compute and also storage efforts to commodity hardware effectively, right? Google back then around 2000, they couldn't afford a big box, right? So they looked into how can we get the same out of essentially a network of commodity machines. And by doing that, they had to acknowledge the fact that a lot of the stuff that you would typically do by, getting better hardware in there and more reliable hardware, they essentially had to do on the software layer, no matter if you did it in the operating system layer or application layer.
Yeah, how much of this story is about Google releasing papers and the world following suit and implementing those ideas?
To be honest, I would say at least 60 to 70%, no matter where you look, Hadoop, now pretty much everything around containers and so on. Wherever you look, you see either so-called white papers, which essentially are just, research papers. And then people in the open source try to, based on what they read in these white papers to recreate that in the open source. But yeah, I guess way over 50% of the things we see nowadays in the open source world are directly or indirectly inspired by what Google has been doing in the last decade.
Do you think that big company architectures like Google are generally a leading indicator of where smaller company architectures are going?
I think the lessons learned can be very, very beneficial. Obviously, the one, factor or aspect that open source, not software, but open source really is eating the world. That's huge, right? And where do these open source projects get their ideas, their inspiration, their blueprints or whatever from? Well, from companies such as Google. It's not Google alone. There are like other companies that also, like LinkedIn, for example, with Kafka and so on and so forth. Either generally developed systems, or in the case of Mesos, it would be Twitter, who made that open source project essentially mainstream and usable for folks.
How are the distributed systems needs of different companies changing?
So we have witnessed, I believe, starting in around 2000 again, this NoSQL movement, the kind of liberation of the straitjacket of the relational database and database vendors, and then through Hadoop, a whole slew of distributed engines, essentially, be it Spark, be it query engines like Drill or Impala or PrestoDB from Facebook. And now we have this variety, this zoo of, and as you might know, Zookeeper being one of these elements there. That's not a coincidence, right? The Yahoo guys exactly named it for that, because it is a zoo, right? A zoo of things. So we are a bit out of our comfort zone compared to around 1995 or 2000. All you needed to know in terms of storage was essentially MySQL, right? That's it. And nowadays, you need to, are you in the cloud or on premises? Do you go for, relational databases, or some NoSQL or whatnot, time series databases, and so on and so forth. And in each of the categories, you have a sheer endless variety of things you can choose from. So this diversity that's great. That's also, if you look at the gene pool and so on, right? Diversity is always great, but it is very challenging for practitioners to just to get an idea of what is actually the right thing for my use case, for my application.
Now that we've developed a motivation for this ecosystem, what is Apache Mesos and how does it fit in?
Right. So a while ago, around 2009, I believe, Ben Hindman, he's the VP in the vice president for the Apache Mesos project in the Apache Software Foundation. Back then, he was a PhD student at Berkeley, and he looked with a couple of others into that idea of creating a new kind of resource manager. So imagine you have a cluster of machines, nodes, and you want to be able to create new frameworks, new things that could be, batch oriented, that could be low latency, whatever, very quickly. Wouldn't it be great if you would have a lower level abstraction that just makes this cluster of machines, this network of machines, look like one big box? I always jokingly say that Mesos is essentially mainframes done right. And that, by that, I mean, effectively, just as with a mainframe that looks and feels like one big machine, that's exactly what Mesos does for you. It makes one cluster of machines that are individual machines that are communicating through a local network look like one big box with terabytes of RAM and so many CPU shares and so on and so forth. And based on that, this is the core building block, a bit like the Linux kernel to Ubuntu or CentOS or whatever. Then you have a lot of things out there, so-called frameworks. For example, for long-running jobs, you would use Marathon or Kubernetes. For things like, cron jobs, cron job-like batch jobs, you would use Kronos. You would have big data frameworks like Spark and Elasticsearch, Cassandra, and so on and so forth. But the core is really Mesos that abstracts all the resources in the cluster away.
So Mesos provides this fine-grained resource sharing and isolation. If a developer wanted to get this from a data center without Mesos, prior to the Mesos world, what would that developer have to do?
So you as a developer would then be challenged by the fact that you have to deal with, let's say, you have a data center, which is a very fancy way of saying a cluster of machines, and you would need to treat all these machines as individuals, right? So you would probably have some way of SSHing into the machines and launching stuff there. You would need to take into account that these individual machines, they contribute to your application with their local RAM and their local hard disk drives and so on and so forth. But you would need to write a kind of coordination layer that would say, I need, let's say, 1 gig of RAM. So I need to find a machine where there's 1 gig of RAM available to launch that task, for example, right? So you would end up doing what Mesos does in a generic and reusable way per application, and that is obviously and that's the old IT trick, right? You always have one level of indirection, and with that you solve everything, right?
Right. So what are the types of operational problems that Mesos alleviates? I mean, you kind of alluded to it in the sense of alleviating this need to write a coordination layer.
Right.
but in practice, like what are the when you think of ops guys pre and post Mesos, at least, what are the problems that Mesos alleviates?
Right. So again, I will point out that no one out there is using Mesos on its own. It equally, senseless to say someone is using the Linux kernel. That doesn't make sense, right? You need something around that. Unless you're able to do the syscalls and whatnot, you're not using the kernel as such. And in the same way, without the frameworks, Mesos wouldn't do any good, right? Mesos wouldn't be useful at all. So Mesos is essentially per design saying Mesos, the Mesos distributed operating system kernel does not try to schedule any kind of workloads, but it just says I'm managing the resources and offering these resources to the so-called frameworks, and the frameworks then really implement the scheduling depending on what kind of workload they have. As I said, Marathon, for example, for long running, Chronos for batch, and so on and so forth. And there the actual scheduling decisions are taking place. And this tool level, at least in theory, it would be interesting to have a study on that. Enables people to write these frameworks much faster, rather than they would, comparable without Mesos, have to write it from scratch. One anecdotal evidence we have from our CEO who wrote Chronos. And he essentially said, like, hey, I didn't have to write any kind of networking stuff at all. I was just, focusing on the functionality and the UI and so on, and everything in terms of the networking and dispatching the tasks and so on and so forth. Everything was taken care of by Mesos.
So as you've mentioned, the scheduler in Apache Mesos called Marathon. This is probably the most important part of it to focus on. Mesos provides a 2-level scheduling mechanism that decides how many resources to offer the different frameworks, and then those frameworks can choose which resources to accept. Can you give an example of how this might work in practice on a Mesos cluster with several different frameworks running?
Right. So obviously, again, why is that different? That's exactly upside down to what you would normally expect, right? Normally you would expect someone demands something, says I need these resources, and then gets these resources allocated. And in the Mesos world, it's really upside down. So the Mesos...
Would you call that way that you just mentioned, would you call that a fair scheduler?
It is. The core of the Mesos, of Mesos is really, it's called DRF. And this, core algorithm essentially guarantees fairness across different resources, which is quite unique. So resources being things like, TPU, RAM, and so on and so forth. So it depends on the type of workload, but the DRF algorithm, domainant resource fairness algorithm, guarantees this fairness across different types of resources, across different workloads. So coming back to Mesos and Marathon, and then potentially other frameworks, what happens essentially is it's always triggered by a user, right? So if I don't do anything, if I don't say, hey, launch this Nginx web server, then obviously nothing will happen, right? Mesos will, let's say we have 3 different frameworks, Marathon, Chronos, and Spark. And Mesos will offer the cluster resources, as I said, CPU, RAM, port ranges, disk, and so on, to the frameworks, but nothing will happen because no one launched a job or anything. Now, let's say I say to Marathon, hey, launch this Nginx web server. And I specify I need at least 500 megs of RAM and these ports and let's say half CPU share or whatever. And that is the input, that is the trigger for Marathon to start looking and accepting resources as they are offered by the Apache Mesos kernel. And now let's say you, Jeff, you are issuing at the same time a Spark job, right? A Spark batch job. And also specify certain, requirements in terms of resources. Then Mesos will, also after it has offered, for example, first my Marathon framework, the resource, it will offer you resources, and we are all happy. We can all, progress. We can all execute, depending also on on decision of the administrator. Because, for example, someone might decide, well, Jeff is a great guy, but he's only doing the analytic stuff, and so he can work with some Slack resources. But Michael is running the Nginx, and he really needs a lot of resources. So there might be some roles and some static partitioning that I, in terms of quality of service and so on and so forth, that I might decide that certain frameworks are prioritized or should get more or whatever. But other than that, that's how it works. That's exactly how resources are offered.
So we've done some shows that have touched on microservices in this show. Is Mesos useful for doing service discovery and like orchestrating these different microservices?
So the answer is yes and no, because Mesos itself is so low level in the abstraction that Mesos itself doesn't do anything in terms of service discovery or whatever. But it does provide, for example, if you think about, you have let's say an container orchestration tool such as Kubernetes or Marathon or whatever you have, or HashiCorp's Nomad or Docker Swarm. At the end of the day, all of them, what they do is, what all of them have in common is, they decide, okay, I'm going to launch this container on node 1, 2, 3, 4. Right. So you as an DevOps administrator, you don't know, and you don't care, and you don't have to care. That's the beauty of it, where this container is launched. But then you have a problem, because if you want to connect to that container, let's say again, Nginx, for example, web server, you don't know to which node to connect, to which IP. So you need the service discovery, right? Who knows where that has been scheduled, where the container has been scheduled? Well, the scheduler. So Mesos provides this mapping of container IP and port, potentially, depending on what you're using there, different options available, and the container itself. So on which node does a certain container, which node IP port is a certain container available. And that is then used, for example, Mesos DNS, which is a DNS-based service discovery. There are plenty of others, Console and etcd-based, Zookeeper-based, and many, many others. And in fact, I'm currently writing on a book, which is currently in production at O'Reilly, around Docker networking and service discovery will be published in January. And there, it's a free book, so everyone can download it for free and talk about these things in greater detail there.
Why did you decide to write that book?
So the editor I met there, Brian and myself, we discussed it at Strata in New York, and somehow figured that this area is kind of like not that greatly covered yet. It's a rather new and fastly evolving, to be honest, field. So it makes sense to have one of these. It's a short book. It's like 60 pages or whatever. It makes sense to cover that topic, even in this rapid change environment. And that's what we did.
Interesting. So now, this seems like a good segue into talking about Kubernetes. Now that we have an idea of why Mesos is so powerful. So Kubernetes is an open source container cluster manager. What is the history of Kubernetes?
So it's essentially the story of how Google in the last 10, 12, 13, whatever years learned, and lessons learned from what Google did there, launching nowadays reportedly some 2 billion containers per week. And they had originally the Borg cluster manager, and a couple of years ago there was another approach with Omega. And at some point in time, they decided to, open source or based on their knowledge and their lessons learned with mainly with Borg, to open source that, a complete rewrite in Go from scratch. And Kubernetes is a highly successful open source community project with many contributors. Amongst others ourselves, Mesosphere. We're building Kubernetes on Mesos, and it's really fascinating to see what uptake and adoption and love Kubernetes enjoys out there. And it's in general, if you're all in regarding containers, you have your CI/CD pipeline set up for pumping out Docker images or whatever, then you should go for Kubernetes. No doubt about that, right? It's very, very straightforward. If you're not ready yet, if you want to you have some quote unquote legacy applications, you don't want to put in a container or whatever, then Kubernetes is unfortunately currently not an option. I don't think that this will change. It is, I think, per design a container, orchestration management, whatever system.
What were the big lessons learned that Google took away from its work on Borg?
Right. So there's a really good paper just came out this year, funnily enough. Because the predecessor Omega, this paper already came out in 2012, so kind of upside down again. But the things they mentioned there in this paper are things like the pod as a unit rather than a single container, so that things that belong together and should live and die together are scheduled together on a certain node. Things that are, I think, already now being backported to Borg are how to organize things with labels rather than having a strict and rigid hierarchy of things. Different use cases or different organizations or whatever might view things in different light. So having labels is very simple because everyone can apply his or her labels and can query things like pods or replication controllers, services, and so on. So all these abstractions that Kubernetes offers from their point of view, and everyone is happy. The idea of a replication controller that essentially looks at something that you tell, I want to have 3 copies of this web server, and the replication controller takes this order and compares it with the real world, and then makes sure that this order or the desired state, as they say in the documentation, is always the same as what it experiences in the cluster. You can do things like rolling upgrades, and you can do things like online debugging. I've recently blogged about that, which is really cool, that you can essentially just take one of these pods out of a replication controller, and the replication controller will say, oh, oops, there is one pod missing, and launches another one, right? And you keep or you can then debug this container online. And there are many things around that, details, but these are some of the lessons learned, and this relative, like on the one hand, you have very powerful concepts or abstractions like services that kind of give you a stable interface for the pods that come and go. On the other hand, you have a very fine-grained control over many things, be it quotas and volumes and so on and so forth.
Over Thanksgiving, I had a great idea for a web app. So instead of spending time with my family, I locked myself in a room and I started building this application using Express.js because I love full-stack JavaScript. So I was testing my application locally and I was making great progress. So I decided to deploy it and share it with some of my friends and get some feedback. I used DigitalOcean. I signed up for an account using promo code SEDaily, and in 15 minutes, I had my app deployed to a server and running. It was that simple. This was really the first time I had used DigitalOcean. So if you're like me and you like building stuff and you have ideas for projects, give DigitalOcean a shot. It is the fastest and simplest way to deploy an application that I've ever used. If you want to give it a try, go to DigitalOcean.com and use the promo code SEDaily to get $10 in free credits. Check it out. So we should zoom out a little bit for people who are just loosely familiar with containers and don't really understand how they work. A container is a subset of a file system, or what is it exactly? Can you explain to our listeners how a container works?
Right. So I always say, think of a VM, think of a virtual machine, then forget everything you know about it, and then we can start talking. So don't think of a VM. It is not a VM. It is really just a application level dependency management tool. That's a bit of a mouthful. What I mean by that, like if you're familiar with Python, then you might know virtual env. So you essentially can guarantee that for your application, the exact libraries and whatnot, what you need is there throughout the entire lifecycle, from your machine over to QA to production and so on. So it's really from the developer perspective, something where this old, it used to work on my machine. It's unfortunately it doesn't work on the production server. That goes away, right? You can say, this is exactly what I need. This is the web server. Here are the libraries, the dependencies and whatnot. And you freeze that in time. That's the image, right? And then you can ship it. Then you can, run it wherever you want. And this is the big thing. It's really, really not a VM. Yes, there are things that look familiar, like isolation, the things like that you can look at, you can say, and this container is supposed to, maximum consume this bandwidth or RAM or whatever. And if it goes above that, then kill it. But I would argue that it's from like how people are supposed to use containers that's totally different to VMs. They're really lightweight. I alone launch hundreds and thousands of containers per week. Not Google, but I still do it because it's it's just a really like a process group on steroids, right? It's really just a very nice way for developers, DevOps, to define their application environment and to make sure that this looks and feels the same throughout the entire lifecycle.
Yeah. And so, as you mentioned before, one of the things that the Borg paper touched on was this idea of pods, and this got carried over into Kubernetes. So, you mentioned the importance of this resource co-location within a pod. What is the purpose of a pod? Like, why is that co-location so useful?
Right. So I would argue that very, very often, if you look at, no matter if you look at toy examples or what people are testing or production insights, we have less concrete examples available. But whatever you can find in terms of what people share, you will not find that many pods that really have many, many different, like 2 or 3 or 4 different containers. But you very often have this setup, and we recently did a demo, a time series demo that exactly uses that pattern, that you have one container that is about, for example, a web server that displays something that provides a user interface, and then you have another container that pulls some data from somewhere. In our case, it was an S3 bucket, right? And the beauty there is that you can change, right? You can say, I don't want to use Nginx anymore. I want to use something very new, let's say Apache web server, or the other way around, right? And then, you can do the same thing to the other pod. You can say, initially I wrote this, S3 bucket pull container in Perl, and now I'm going to rewrite it in, Go, and nothing changes, right? Because the interface is the same. They probably will share the data through a local volume, and within a pod, all the containers, they see each other on localhost. They share the data and the volume and so on. So they are very, very tightly coupled. So you can evolve these things independently. You can use this, for example, this pulling something from S3 in different contexts. You can use it, once for your web server and once for some backup mechanism and so on and so forth. So you have this reusability, but because they are scheduled together, you have the guarantee of data locality, because it simply wouldn't make sense to have the one container on one node and the other container on the other node, and then how do you get the data from A to B? So you have this sweet spot, or you can decide where the sweet spot is between reusability and data locality and coupling.
And so when we were talking about Mesos, and we talked about the scheduler of Mesos, Marathon,
right.
Marathon looks at resources being allocated. When Mesos, if Mesos is interfacing with Kubernetes, is the idea of resources, does that get translated to pods, or where? Like, what is where is the interface between Mesos and Kubernetes?
Right. So from from like if I use Kubernetes through Mesos or the DCOS, our product, I don't see a difference, right? It looks and feels the same. We might not be there yet in terms of covering the entire 1.1 API, but it doesn't. It's the same kind of interaction. The thing is, from Kubernetes' point of view, it's a bit like I always compare it with the matrix. Like Kubernetes lives in a matrix there, and the matrix being Mesos, right? It doesn't really know that it's actually running under the control of Mesos. So the trick there is really to provide to translate this pull model, if you wish, from Kubernetes, where a pod says, "Hey, I'm here and I want to have these resources and run," to the at the end of the day, there is a component there in Kubernetes on Mesos that because it's just a framework, really, from Mesos' perspective, that needs to wait and hope that the right resources fly by, that it can accept them, right? But as I said, it's really from the end user perspective equal. From the administrator perspective, it's obviously different because Kubernetes is not alone there. It's just from Mesos' perspective, just one framework. You might have others, and then it depends on how are they using certain systems like. Zookeeper is not a problem with Kubernetes because Kubernetes is using etcd to maintain the state of the cluster throughout, like what pods are running and so on and so on, and mappings and so on. But you can imagine that there are certain services, let's say, I don't know, Marathon and Storm, for example, both use Zookeeper. And if you don't decide to, for example, having a separate Zookeeper instance or Zookeeper cluster really for Marathon and Storm, then it might be that, if you have a busy Storm topology, that might somehow influence your capability of launching new applications in Marathon, right? So these are best practices that come out of using this stuff in production systems, production environments, that where you say, maybe it's better to have like one system Zookeeper, right, where only Mesos and Marathon use that, and one other for all the frameworks or per framework that uses Zookeeper or whatever. But that's the kind of problem that you then see, which you don't have if you have like standalone vanilla Kubernetes, right?
You gave a talk at the London Mesos user group, and it was called, "Can I Have Mesos and Kubernetes?" What were you trying to convey in that talk?
Right. So the question there really was, is it possible? Does it make sense? And I tried to make the point that there are cases where you really want to have it if, and that's the if you are running Mesos, right? So it doesn't really make sense to say, hey, if someone says, hey, I want to use Kubernetes to go for Kubernetes on Mesos, right? That wouldn't make sense. But if you're running Mesos anyways, then you also have the option with Kubernetes on Mesos to run, to have Kubernetes applications, right? And that was the bottom line. And I, gave a demo, showed something there. And don't forget, the problem there is that if you have an application, a legacy application or whatever, that you do not yet want to put into a container to build Docker images or Rocket, for example, then you cannot use Kubernetes, right? So you might start with Marathon or whatever, but you do want to have the option to benefit from the power and flexibility of Kubernetes.
Do you see the majority of Mesos users leveraging containers in some form or fashion?
So the truth is, everyone is using containers because there is no other option. Even if you're not using Docker containers, and there's the big confusion that, if you say containers,
right. That's what I should have
99% of the people out there, or 90%, will probably think, he means Docker, which is not the case, right? Like containers as such, they have been around for more than 10 years. Fortunately or unfortunately, they have been renamed to C groups, and it was effectively a bunch of Googlers who contributed all of that. So a fancy way of describing it, because it's just really the combination of namespaces, like, user namespaces and file and process namespace and network namespace and C groups that make up a container. And Docker is just one very convenient UX around that, including the client and the registry and so on and so forth. But Mesos, in any case, even if you just say do execute while true, do echo hello and then sleep 0.1 and done, right? Even if you just execute this very simple shell script, then Mesos will wrap that in a container. So there will be C groups, and there will be depending on what you define there, namespaces set up and so on and so forth. So even if you're not using Docker, there will be a automatic containerization done by Mesos, but it's transparent. You don't notice. You just say, here, that's the Java application or the Ruby script or the whatever you want to execute. Anything that you can execute locally on a Linux shell, you can execute in Mesos and Marathon. And so it's happening anyways. It's just a matter of if you have to put an effort into it and building actually these Docker images or not. So,
as you've said, we've had Linux container technology for something like 8 years or 10 years or whatever. But, more recently, Docker came around and made things more usable. Could Kubernetes have reached the type of adoption that it has without Docker, or was Kubernetes even feasible without Docker?
I personally think that either someone at Google was very, very closely paying attention to it, or it was a huge coincidence. I don't know what, but it's clear to me that without the popularity and all the buzz that Docker generated, Kubernetes would probably have had a harder time. So it certainly benefits from that. Mm-hmm. But to be honest, I see, Kubernetes is not Docker alone. You can do Rocket. You can, run very soon, hopefully with 1.2 of Kubernetes, the OCI, the Open Container Initiative, runs HESPAC and so on and so forth. So I would argue that now, thanks to Docker, this container field has been made mainstream, and now Docker and they are still probably the number one thing used by the majority of people out there. But Kubernetes is certainly more than just Docker images and Docker containers.
So in that talk where you were talking about Mesos and Kubernetes, there's an interesting slide that is titled "Let's Talk About Workloads," and it shows this gradient from left to right, where it shows batch and streaming and platform as a service. Platform as a service is on the far right, and batch is on the far left. Streaming is in between. Can you describe that gradient and where different technologies fall along it? And what was the point you were trying to make with that slide?
Right. So first and foremost, I need to make one thing clear. I lifted that. I stole that slide from my good old friend Timothy Sinclair from Red Hat.
Yes, and the attribution is in that slide.
Yes, it's just, I didn't make up this wonderful slide, but it very much resonates with me and what I've seen. So in a real world setup, in any kind of serious, bigger application out there, you will find these different workloads, right? You might have some batch, some, reports that need to be created every Monday morning, whatever. You might have some sort of stream, more or less stream processing, and you have some kind of PDS level things. And the question there is always, will you need different base execution environments? I now put it in a very generic way to drive all these workloads, to run all these workloads or not. And the idea behind Mesos somehow is that it is the base. It can function as the basis for all of that. And then depending on what you're looking at, like a batch would be like covered by Kronos, and we have a couple of things like Spark and so on that would cover stream processing, for example, and then you would have Marathon and Kubernetes for the PES part. But in all honesty, as long as you're cool with the containerized part, Kubernetes is also covering quite it. So Kubernetes, it's a bit unfair to put Kubernetes like only for the PES stuff there, the right-hand side, the red side. But it's really, Kubernetes also allows you to run perfectly well, databases and so on and so forth. That was the basic underlying idea of this spectrum of workloads.
And there's another slide where you say that Kubernetes allows for 100% containerized workloads, and Mesos allows for containerized and non-containerized workloads. But using Mesos and Kubernetes together, a user can have hybrid workloads. Can you talk about these different workload use cases?
Right. So it's maybe a bit technically not correct to say non-containerized, because as I mentioned earlier on, even if you just launch whatever Python or Java or whatever, right. Mesos will wrap that in or will containerize it for you. What I meant by that is, if you are using Kubernetes, then you need to commit to and upfront be aware of that you will be doing nowadays probably to 100% Docker images, right? You will need to make sure that you have policies around that. Maybe you decide on a couple of base images, and how do people derive from these base images their own application images, with what kind of registry, how are these images distributed to the nodes in the cluster, and so on and so forth, right? Whereas with Mesos and Marathon, you don't have to do that, right? You can simply say, hey, do this groundwork or whatever for me. And you can combine these two things, right? You might, and actually this time series demo we did there pretty much demonstrates that very nicely, where to use what in what way. And I might just include a pointer to that. It's up on GitHub, and there's also a blog post, so people can actually try out things for in their own time to see how things work. But that's what I meant with containerized and non-containerized. Whereas, as I said again, non-containerized is a bit misleading here, because under the hood it will be containerized. It's just that the effort is not on your end or on your side.
Does Kubernetes provide any cluster-wide services that Mesos can take advantage of?
So the answer to the first part is absolutely yes. There are a number of things like Hipster for monitoring, and volumes, persistent disks, and so on and so forth that are in general available throughout. It then depends a bit on the environment. Like if you're going to, for example, Google Container Engine, which is funnily enough called GKE, because the C was already used for Google compute engine. Then you have wonderful support. You have everything integrated, wonderful. You just say here this GCE persistent disk or whatever, and wow, you got your volume there, and you just say load balancer, and you have a wonderful load balancer, and Hipster comes for free. So you've got everything. If you're doing a bare metal Kubernetes deployment on your own in your own cluster, then guess what? You need to do that yourself, right? You need to come up with a load balancer solution, come up with a monitoring solution. But you probably will use Hipster. But all these things, you're like, well, what about these persistent disks? You might need a NAS file somewhere there, and need to build these persistent disks on your own. So it depends on the environment. But in general, yes, Kubernetes comes with a number of cross-cluster functionality features, but then it depends a bit on the environment, how they are actually implemented and instantiated. And does it? So the second part was, is it something that can be used from Mesos? Yes and no. It again depends. Like things like Hipster, that's great, right? You want to monitor all your containers and how they're doing, and their utilization and so on. That's certainly there. Load balancers being another example. Other things might be a bit specific to Kubernetes. I'm maybe pulling things out of the thin air, but for example, the idea of a pod does not really exist outside of Kubernetes, right? So anything that deals with a pod it's not really reusable in another context within Mesos.
So when we talk about Mesos and Kubernetes, there's another couple things I've heard in this space. Docker Swarm and Amazon ECS, and I think there's probably some other technologies. How do these compare? Are these like mutually exclusive technologies, or which ones are the mutually exclusive technologies? Maybe you could help me sort out which ones.
So ECS, the Elastic Container Service, I believe it is called. And if I'm wrong, I'm pretty sure that I get a friendly reminder from someone from AWS.
I think that's really right.
Very much after that, you get their stuff right. It's really a cool system, and I would argue if you are all in regarding AWS, then consider using it. It's really just what I don't like about it. It's obviously not open source. AWS doesn't do a lot of open source, and it's not very portable. So if you decide to do your stuff within ECS, then you're effectively locked in. For some people, that's not a problem because they're anyways all in. Okay, but if you want to have this option to, you might want to do some hybrid stuff. You might want to have something a bit on your own data center and the other part in the cloud, or you might swap or change from one cloud to the other because of whatever reasons. Then ECS, that's the challenge there, right? It's not based on open standards, on open source software. So you're experiencing a kind of lock-in. But overall, it's a very great, awesome, nice system that certainly, especially if you are all in AWS, certainly is a great way to go. Docker Swarm is early days. It's not what I would consider a full scheduler yet because it doesn't really take care of the entire life cycle. It allows you to launch the containers, but it doesn't keep them alive, which to me at least is a kind of essential thing for a scheduler, that it will restart the pods or the containers somewhere else. But because it's quote unquote Docker native, which for some people is really, really important, it's certainly it will have its market share and growing. So the question with Docker things is always, and that's the same for networking and for storage and whatnot, as maybe people have heard, that Docker has this idea of batteries included, but you can change them. The question is, are the included batteries good enough or not, right? So you can exchange the scheduler with whatever Mesos or whatever, but so we from our point of view, from Mesosphere point of view, we just view the other way around, right? For us, we're trying to be an operating system, and we don't really care if you're running Marathon or Kubernetes or Docker Swarm on top of the DCOS. That's the idea. So from our perspective, whatever you like, but certainly on that level, like from Kubernetes to Docker Swarm and ECS and so on perspective, there's certainly some competition going on there, and I would assume it's not a winner take it all market, right? Everyone will have their niche and their user and fan base.
Yeah, interesting. So the Mesos project was actually, I didn't know this before reading the Mesos paper, but the Mesos project was the genesis for Apache Spark.
Yes, exactly.
What was the experiment that the Mesos creators wanted to run when they built Spark?
Well, they essentially, when I earlier said we don't have a proof, that would actually be the closest to a proof. They wanted to show off how easy it is to build something new, some new kind of distributed processing system with or on top of Mesos, and they did that with Spark in a very, very short time and a few lines of codes. I can't remember the number of lines of codes, but way less than if you would have built that from scratch. And yeah, that's the general idea. And then later on, people would do their own things. So we now have Spark and the whole ecosystem around Spark with the Databricks folks and Ben being at Mesosphere, one of the co-founders and architects of Mesos. That's
the amount of technology that's come out of the Berkeley Amp Lab is pretty astounding. Like Spark, Mesos, we're doing a show on Tachyon in the near future.
Yeah.
What do you think led to this degree of innovation? I mean, I'm sure you've interacted some with Ben and maybe these other guys. What led to this?
So I think their long-term view, right? So the no matter if you look at AmpLab itself, the organization, or what they call the badass stack, right? The Berkeley, whatever, data analytics stack, whatever, badass stack. This vision of, we're not doing one little thing here. We have 10 years vision and 10 years founding, to be honest. And that attracts certainly people, good people. And then it certainly doesn't, it certainly helps that you're close to the big guys like Google and Facebook and whatnot. That certainly, and there was also at that time around Omega 2009 or whatever, Omega Mesos. That certainly these teams they had quite an exchange of ideas and discussions, and they mutually benefited from these discussions.
Yeah, it also seems like Ben and Matei at least had a lot of industry experience when they developed these these things.
Yeah. They were not their typical or your typical academics, and I guess I can say that I was 12 years in academia, so I think I see the version.
You were shell shocked.
No further comment on that. But
no further comment.
Yeah, very.
So
very
we have. We have a few listener questions from the Slack channel. I posted on the Slack channel this morning that I was going to be interviewing you, and asked if there were any listeners who were interested in questions there. I did get a few questions, and if anybody's listening and they want to join the Slack channel, by the way, you can go to softwareengineeringdaily.com and sign up. So one of our listeners, George Adams, asks, to what extent does Mesosphere DCOS rely on Cassandra to ensure data isn't lost when a machine on AWS goes down?
So the question, if I understand it correctly, is if the DCOS relies on Cassandra.
Yes. Does it rely on Cassandra?
No. So you can use Cassandra as one of the services. And there is something what we call the Infinity Stack. It's kind of like big data IoT stack that uses heavily uses and has as its center Cassandra, but there is no hard dependency on Cassandra for the DCOS as such.
So George also asks if a Jenkins instance goes down, how are its configurations migrated? What if I have things that require a static IP address for whitelisting?
Right. So that's an excellent question, and there are unfortunately many possible answers because it very much depends on how you're using it. So we have one case where a large organization that has some 4,000 developers essentially has one Jenkins per developer, right? It also depends on how you set things up. If you have, for example, one IP per container, which is, I think, since kernel version 3.19 or whatever supported, then you can do other things than if, you need to somehow juggle around with your ports and need to make sure that you don't have any conflicts there if you're using Docker bridge mode. So, it really there is unfortunately no generic good answer there. It very much depends on your environment, but I'm more than happy to if someone reaches out to me via whatever Twitter or on Slack or mail or whatever, I say, okay, this is my environment, this is what I want to do, to say, okay, here are the two options that probably work best for your case. But unfortunately, with the data or the description I have here, I cannot give a concrete solution for this because it's underspecified. I don't know many things about it.
So this isn't exactly car talk for for the data center operating system. Right. So another power listener, Name Node, asks, what do you think about OneOps from Walmart Labs? I don't know if you've heard of this product.
Yes. As far as I remember, of course I could Google now, but as far as I remember, that was something OpenStack related.
Let's see. I think I have it open here. It's
I'm not entirely sure, but I believe it was OpenStack related. And That, as far as I remember. And so the question is, to me, to a certain extent, what's the motivation of Walmart to do that? Walmart is a retailer, and AWS is a retailer, and there might have been reasons to do that. I welcome any kind and every kind of open sourcing, no doubt. I don't know the motivation for that specific one, but I can't remember the details. But as far as I remember, I think it's something to do with OpenStack. Some OpenStack, dependency or whatever. I cannot, for the life of it, I cannot remember what the
don't worry about it. That's a super specific question. So name node, we need more general questions in the future.
It says, OneOps supports public cloud service like AWS on OpenStack to current. Yeah. So it is an OpenStack.
Okay. Yeah, we need to do a show on OpenStack. I haven't done a show on that yet.
Okay.
So, let's start to close off. I want to talk a little bit about Mesosphere. What kinds of products does Mesosphere make?
So, Mesosphere, as such, really only has one product, and that's the DCOS, the Datacenter Operating System, which is a distributed operating system. People might remember, if they're longer around, Plan 9 from Bell Labs. So it's really a this kind of distributed operating system, and it happens to use Apache Mesos as its kernel. And we're trying to productize the experience that our co-founders have running Mesos and several Mesos frameworks or services at scale in companies like Twitter and Airbnb and so on. And make it very, very simple and easy for people to, launch their Spark and Elasticsearch and Kubernetes and whatnot cluster. And it's really a beautiful thing. I mean, I've spent, in my previous life, a lot of time setting up this and that database and this and that framework and so on. And now it's kind of like, it's a one-liner, right? It's DCOS package install Kubernetes or Spark or Cassandra. And then I wait for a couple of minutes and everything is there. And, that's the beauty of it. So
one thing I think about with this stuff is like, and I kind of alluded to this earlier with the potential of the big companies being a leading indicator for smaller companies. But, when we think about really young companies these days, we think about their compute stack as generally being not really similar to the compute stack of a giant company like Twitter that has, needs for all of this compute power. But it seems like if that were more accessible, people might take advantage of it more aggressively. Is that one of the big visions for Mesosphere, like making this stuff more accessible, more usable, more one-clicky so that people will take advantage of it?
Yeah, I guess you're spot on. I guess that's exactly what many startups are after. It's the flexibility you need. You need to be able to should your application or whatever you're doing there be an overnight success, that you are immediately be able to serve so and so many customers or users. And that flexibility together with you want to make sure that the things you're doing there are somewhat sustainable. I'm not saying that you're not planning for a code base being around for 10 years, but you don't want to make things that fall apart after 3 weeks, right? You probably want to benefit from something you write and benefit from it more than a week or two. So this flexibility with it has. And a part of it, one aspect might be portability. That's why, things like, Mesos or Kubernetes are so powerful, because they don't lock you in to one proprietary interface that you can only have in one specific cloud. But it's up to you to decide, you might start, due to whatever reasons, let's say in AWS. And at some point in time, you might say, I really want to move to some on-prem deployment, or the other way around. And you can do that with, Mesos Marathon, with Kubernetes, and any other open source project, while with proprietary standards and APIs and interfaces, you can't. You're locked in. And you want to be that flexible, right? You want to have that flexibility, I suppose.
That's great. Well, that seems like a good place to stop. Michael Hausenblas, thanks for coming on to Software Engineering Daily. It's been really interesting talking to you.
Thank you so much for having me, Jeff. Thank you.